Today we're going to talk about thyroxine. This is your thyroid gland. Well, maybe not yours, but somebody's. The thyroid gland is located here. The thyroid gland makes hormones called, thyroid hormones. These include tyrosine, thyroxine, triiodothyronine, and reverse T3. They function to help the body with energy, body heat, and general homeostasis. This is thyroxine, also known as T4. It's one of the thyroid hormones, and it's the one we'll be talking about today. T4 is synthesized by thyroglobin and iodine, I minus, and thyroid peroxide helps with this reaction. First, two iodotyrosines are created. This step is called the organification of iodine. Then again, using thyroid peroxidase, T4 is synthesized.
Alright, so now we're going to go a little more in depth into that synthesis. So here we have our two tyrosines, and they're both bound to the thyroglobulin. Alright, so the next step is the organification of iodine. And this happens with a compound. It's iodine that's been oxidized by peroxide. To make that a little simpler, we're just going to draw it as I partial positive with an O partial negative. So then that benzene ring of one of the tyrosines will then attack that partial positive, and we'll get an electrophilic substitution 4 times, twice on each ring. Next, 2 electrons are going to be pulled from the structures as a whole, one from each structure, creating these radicals. The radicals then form a bond, but they're still bound to that thyroglobulin. The next step, that second now iodotyrosine will break away and try and recreate its conjugated system, resulting in thyroxine.
As you can see, T4, or thyroxine, has quite a few functional groups. We can see there's an alcohol, an ether, 2 aromatics, a carboxylic acid, and an amide. The molecule also contains iodine. Due to its large size and the fact that it's a halide, iodine makes a great leaving group, creating the reactivity of T4. If iodine is removed from the first ring, T3 is created. T3 is a more active thyroid hormone than T4 in the human body. With its many functional groups, it's no surprise that T4 has many interactions. According to PubChem, that among its properties, T4 has 3 hydrogen bond donors, 5 hydrogen bond acceptors, and exists in resonance forms. T4 is also described as slightly soluble in water. The most important reactivity is the hydrogen bonds that can be formed by the terminal alcohol groups. This seems like it wouldn't necessarily occur due to steric hindrance. However, a study done in 1976 proved otherwise. This allows the T4 to bond to TBG, thyroxine binding globin, and other carrier proteins that transport the thyroid hormone to other places in the body to be used. Once in their target areas, thyroid hormones, mainly T3, bind to DNA using structures called zinc fingers. The binding of T3 to DNA affects growth, development, absorption of carbohydrates, protein breakdown, and increases the rate of cellular respiration. Thyroid is an important hormone for life, and hopefully we know a little bit more about it now and its chemical properties.